Hello again. We're ready to begin Chapter 8, and this not only starts a new chapter, but it also starts a new unit. So as you can imagine, we will be looking at some slightly different concerns here, taking all the ideas you've heard so far and used so far and applying these. This chapter is entitled Understanding Populations, and you might be thinking, well, that's a word we already had, and yes, you're correct about that. But we're going to take a much deeper look at how populations interact. Okay, just to do a bit of a review, to check on what you remember and what you need to know. What is a population? We talk about a population. We are talking about all the members of a species living in the same place at the same time. Hopefully you're thinking to yourselves, oh, good, I already know that definition because it's precisely what we had talked about a bit earlier this year. So that is what we're going to be looking at. We also want to consider the fact that a population usually represents a reproductive group. Okay, members of the species reproduce with each other. Now, that can get a bit tricky because what happens is, of course, sometimes a population is changing. It doesn't stay the same, and therefore, when you try to look at, counting out or looking at what's the population, you come up with some problems there. Sometimes populations die or migrate out of a given area, and the term population consequently has commonly been used for convenience sake to refer to the number of members of a species. Okay, that's still the same, within a defined area at a given time, whether or not they interbreed. Okay, so that little condition there is sometimes put on there to help us understand what a population is. So it's usually a reproductive group, but it doesn't necessarily have to be that. Okay. When we talk about the word population, we're talking about the group in general, and of course, the common use of the word population refers to the size of the group. But remember, because we're looking at this from an environmental science point of view, we sometimes don't just talk about the size. We're more concerned about what is the population as to what are these species and where are they and when are they there. Yeah. Let's take a look at the properties of a population. When we're referring to properties of anything, you probably know this from math or maybe even from working with computers. When we're talking about properties of something, we're looking at what makes it what it is. Well, one factor, of course, is size, how many there are there. But this one's a little bit different. Density refers to the number of individuals per unit area or volume. So you think about a condition of space. You give yourself a space in the room, and the density would increase or decrease depending on how many people or how many organisms actually you put into that space. There's excellent pictures in your textbook on page 212 if you wanted to take a look at that. You will notice that, for example, they're showing you a population of flamingos at the top of the page. And they're in a rather small space, and yet there are quite a few flamingos standing in that space. On that same page, they're also showing you a picture of a snake and its population density, which is a lot lower. In other words, there's only one snake in one huge, vast area. So if you still have trouble with that concept, think about our classroom. And right now we have empty desks in the room, and the density isn't too high. But if we were to fill all those desks and increase that by, say, bringing in the two science classes together, all the desks would be filled, and we'd actually have to have people standing around the classroom. What we would notice, or what we would say actually, is that the density of that population has increased. Okay, all the other issues have been met. We're talking about the same space, the same time, the same species, but the density of the population has increased. Another property of a population is that of dispersion. Okay, and that talks about how the individuals in that space are arranged. Because once again, if you look at the classroom, you notice that I have most of the desks closer to the podium, closer to the smartboard are the ones that are filled in. But we could spread you apart, and we would still be talking about now density. But when we spread you apart and perhaps we put you into the groups that you sometimes work with, then we're talking about the same number of species, but we're talking about them being grouped a bit differently. And density becomes a little bit trickier to handle there, but dispersion basically describes instead how you are distributed or arranged within the given space of the classroom. One of the factors we want to consider about a population is how fast does a population change? How does a population grow? And population growth is usually defined by this, it's an equation. Again, it's in your textbook and those ovals, like they like to show you things. And if you want to determine the growth rate, it's pretty much of a simple, pretty logical idea. To determine the growth rate of a population, you have to take the number of births and you subtract from that the number of deaths. And if you think about it, you will know the rate of change. Affecting that, though, there are some things that need to be considered. And one of those concerns is the reproductive potential. Okay, now reproductive potential means how much is this species capable, how much are these organisms capable of reproducing. Okay, when we talk about reproductive potential, then we're saying that the rate that's limited by the number of offspring that each member can produce. You probably know that if you have a cat and it has kittens, a litter can consist of several kittens. But when you talk about a species that might be a little bit different, like let's say an elephant's not going to have a litter of 6, 7, 8 elephants. So the reproductive potential is what exactly can the particular species you're considering do. Okay. The biotic potential is the fastest rate then at which a population can grow, and it refers to reproductive potential because reproductive potential is limiting. You know, if you have 8 cats in a litter as opposed to 1 elephant at a time, you're pretty much limiting what can be done in terms of the growth of the population. So this kind of repeats what I just said. The maximum number of offspring that each member of the population can produce. Of course, that's a factor of size and other conditions as well that we're going to look at in the next couple minutes. To continue talking about reproductive potential, what are some of the determining factors? Well, one of those is that you can have the organism or the species produce more offspring at a time. Okay, keep referring to the kittens, but if that's, excuse me, if that's the case, then you can certainly have a population grow. Another way to change the reproductive potential is to have the organism reproduce more often, and that's not always possible depending on the life cycle of the particular organism you're studying. Another factor that sometimes we don't consider is that some organisms can reproduce earlier in life. You know, some have the ability to reproduce. Some have the ability to reproduce almost from the beginning of their lives on, and others wait until they reach a state of maturity. So reproductive potential is directly affected by these 3 factors. As I said, the first 2 probably are ones that you might have thought of on your own, but the third one is sometimes not considered. Okay. We're going to continue looking at population growth. And again, if you were looking at your book on page 213, there's a map that shows you what happens when you have what is called exponential population growth. Now, you might remember the word exponent from your math classes. We talk about exponents, of course, we're talking about something to a power, you know, x to the 2nd power or 7 to the 5th power, or something of that sort. And the growth of populations changes exponentially. What they're showing you in the chart in the textbook is how over a number of months, and you could have a population increasing, but it doesn't increase like one at a time. That would be linear growth. Okay, instead we're talking about a curve, and there are factors that control that curve, which we'll look at later. But for right now, you need to know that that growth rate is exponential. That means, of course, if you think about this, and if you look at the graph, you'll know what I'm saying, that the populations are growing faster and faster. The book gives you the example of a group of 6 puppies. If a pair of dogs gives birth to 6 puppies, there's 6 dogs in that one generation. And then if every generation has 6 puppies, there are going to be 18 dogs in the next, and then 54, and so on. So the number is getting bigger, faster and faster. And of course, when that happens, then you have to consider what's taking place to other organisms around it, what's taking place in the environment. And that's essentially what we're going to look at later in the year. Okay. Exponential population growth can occur under ideal conditions. well, we say we can do the math and we can put the numbers down and see what happens when we check out the exponential growth. You have to also consider the conditions have to be correct. If the population in question, the population you're studying, doesn't have food and water, then that's going to have a negative effect on population growth, and you might not see the exponential level of it. Okay. The other issue that needs to be considered here is when population growth occurs, part of the ideal situation is that populations have no competition or predators. In the next section of this chapter, we actually look at what does it mean to compete in a population, or various populations competing with each others. What does it mean when a population has predators? Okay. So what limits population growth? Very important idea, one that's studied actually once you get into junior year and you take pre-calculus, something called carrying capacity. And carrying capacity, again, is one of those things that you probably could logically reason out, because it talks about the maximum number of that species that can live in a certain area that the ecosystem can support. Because while the numbers can grow based on the reproductive potential, if there are some factors in the environment itself that make a difference to that population, the numbers may not grow. And one of those factors, of course, as we said on the other slide, would be some things like food or water availability. And sometimes, though, it's not even a question of like there being a shortage of food. Not that there's not enough food that they're fighting for it, but it's simply a case of there's just not enough food there to start with for a large population to exist. So carrying capacity is how much can a certain ecosystem support indefinitely, not just for a day or two, but for an extended period of time. So that will limit how population grows. Another limiting resource, limit to population growth is limiting resources, and that's talking about natural resources again, when they're consumed at the rate at which the ecosystem produces them. So if you have something like grass, something that grows, okay, the way or the time that's involved in the production of that resource limits or determines how fast the population is going to grow. We're going to be looking at some of these concerns when we take a look at some of the things in your textbook tomorrow when you're in class. Then, of course, and this is one I referred to before, you have competition from population to population, but sometimes you have competition within a population. Once resources start to get limited, once the carrying capacity comes to be reached, then perhaps the species themselves starts to compete. And that's when you have issues with, one like wolf against another wolf, where they're fighting for the same food because they're fighting for their survival. So that would also tend to limit population growth. Now, they obviously all link together, so you can't really talk about one without another. If there's plenty of food, then there's not likely to be this last issue, competition within a population. Okay. Again, still looking at what limits population growth. We talked about density before. And population is limited a bit by how dense it is. You can only put so many organisms in a spot. So space is a concern, although you wouldn't think that it should be an issue. And there are two types of space issues that we're going to look at. The types of things that happen when populations are regulated based on what happens how close they are to each other as opposed to how far apart they are from each other. When things happen to the population and if they're close together, perhaps that has a strong effect on them. The example they show you in your book is on page 216, and they show you a forest. Actually, so show you trees in both of the pictures there. And the one picture shows you in a forest when you have something like Dutch elm disease or some kind of disease that spreads from tree to tree, that's very density dependent. So you're going to have a lot of trees dying off very quickly. Now, if you're trying to spread that kind of a sickness from tree to tree and just a couple trees in your backyard, that's not going to happen. On the other hand, a density independent factor would be one, for example, heavy snow or a change in weather. It doesn't matter if you have a lot of trees together or if you have single trees. Population is going to be regulated by the fact that something happened and it didn't matter how close these were to each other. It's kind of like humans. You can get sick when you're in a classroom because you're near other people and you're all spreading your germs around, or you can get sick independently or get hurt independently and need medicine just because of something you've done. Okay, I'm almost out of time, and I believe this is the last slide I wanted to do. We will take a look at this probably in the next section, how species interact with each other. Thanks for your attention, and I'll see you in the second section of Chapter 8.